So we are going to learn how to set up limit of integration to find volume of a solid region in spherical coordinates. So we want to find volume of the solid which is outside the cylinder x square plus y square equal to 1 and inside the sphere rho equal to 2. So this is our cylinder. We take unit circle in xy plane, extend it both ways along the z direction, and we have the cylinder, and the sphere is the sphere of radius 2 with center at origin. Now if you look at this diagram, which is nothing but this upper portion of this solid region above on the positive side of z-axis, then this is symmetric with respect to the xy plane. So if we find volume of this upper part and multiply it by 2, that will give us the total volume of this solid region. So the total volume is 2 times volume of this region, which is equal to the triple integral of the Jacobian rho square sine phi d rho d phi and d theta. Now we set up the limit of integration. To do that, we solve a bunch of equations. First we write equation of this cylinder, which is given to be x square plus y square equal to 1 in spherical coordinates. So we substitute the expression for x and y in terms of spherical coordinates in this equation, and we obtain that equation of the cylinder in spherical coordinate is rho cos phi equal to 1. So we can solve this equation for rho, and we find that rho equal to secant phi. And what this means is that for any point on this cylinder, if you want to find value of rho, then that rho is given by this function of phi. Alright, now we want to find the point of intersection of this cylinder, this point, and the sphere. So what is this point? For that, we substitute rho equal to 2 in the equation of the cylinder, and we find that cos phi is 1 by 2, and that happens when the angle phi is 60 degree. So that means this point, when joined to the origin, this ray makes angle 60 degree with the z-axis. Okay, so phi is 60 degrees here. Alright, so now we are ready to set up limit of integration. So we have a Jacobian, and then we have to take integrate it with respect to rho first. So to do that, we fix the other two variable phi and d theta, right? So what does it mean to fix phi? When we fix phi, then we are the collection of all the points on this hollow cone whose axis is z-axis. And fixing theta means we are on this plane which is perpendicular to the xy plane, and it lies along z-axis on one side. So what is fixing both of them means taking intersection of this hollow cone with this plane. So that will give us a ray of this type or some other ray depending on the values of phi and theta. And now we draw this ray through starting from origin and see its entry point inside the solid region and leaving point. So now we can see for all the rays lying on this fixed plane for theta and the fixed cone, for all these points, the entry point of this ray inside the solid is this surface, which is the cylinder, and equation of the cylinder is rho cos phi equal to 1. So value of rho along this cylinder is secant phi. So that will be the lower limit of integration for rho. And the leaving point for each one of these rays is this surface, which is the sphere rho equal to 2. So the upper limit with respect to rho will be 2. Now let's come to phi. We want to find limit of integration with respect to phi. So for that we need to fix theta, and theta fixed means this plane which is perpendicular to the xy plane and lies along the axis on one side. So now to find limit of integration with respect to phi, what we do is we take this ray up to here. We take this ray here because this is the point where this ray is going to enter our solid region, right? I mean, we can take a ray here, but it doesn't really intersect with the region, the volume of the solid region, right? So we take this ray up to here and we move it along this fixed plane in this direction until we reach the last point inside this upper hemisphere, right? So what is value of phi at this point, at the point of entry? It's 60 degree or pi by 3. And what's the value of phi when we reach this leaving point? Here phi is 90 degree or pi by 2. So limit of integration with respect to phi are going to be pi by 3 and pi by 2. Now we have covered this patch, this plane patch which is perpendicular to xy plane. So if we take this patch and we rotate it around z axis once, and for that we'll be changing theta from 0 to 2 pi, then we would have covered the whole solid portion on the upper half hemisphere, right? So the limit of integration with respect to theta are going to be 0 to 2 pi, and then we can take twice of that and we have our volume. So this sets up the limit of integration to find the volume.